This video will be a prep for rational functions. Specifically, we'll talk about finding the equations of lines, and we'll discuss how it relates to finding the equations of the horizontal, vertical, and oblique, or sometimes called slant asymptotes of rational functions. So, first thing is let's look at a couple of specific types of lines, horizontal and vertical lines. So just a reminder that a horizontal line is a line defined by an equation in the form y equals to b, where b is a constant. So like you could have y equal to 7, y equal to 9, y equal to 3, and so on. A vertical line is a line defined by an equation in the form x equals to a constant. Let's call it a, like what we have written there. But again, it's just x equals to a number, like x equals to 5, x equals to 7, x equals to -2, and so on. So let's look at the graphs, and let me actually do it in a way so you could actually see how it relates to the graphs of the rational functions. Oops, keep clicking the wrong one. Okay, so let's look at this one, and we actually have here in this case the rational function f of x equals to 2 over x minus 3. But let's say if we wanted to draw the vertical line x equals to 3. So remember, if we were to do that, that would be the vertical line whose x-intercept is 3, and every single x-coordinate for each point on the line has the x-coordinate is 3. So that's what you see in green here. Is this is the vertical line x equals to 3. And like I said, the way that it's related to the rational functions is that when we're finding the equations of what are called vertical asymptotes, which are these vertical lines that the function may be approaching on the left side and on the right side, as you get closer and closer to the values where the denominator is undefined, or denominator 0, that we'll have these vertical asymptotes. So this is one example. Now looking at another example here, let's say if I wanted to draw the line, the vertical line that passes through the x-axis at -3. So that would be the equation x equals -3. And so you see that's what we have in blue here. So that's how you would write the equation of a vertical line. Again, it's x equals to a constant, where that constant you could think of as the x-intercept of that line. Now, what if we wanted to draw a horizontal line? Now, again, those are the form y equals to a constant. And let's say in this case, we wanted to draw the horizontal line whose y-intercept is 1. So you write y equals to 1. And in this case, you can see in green, that's that horizontal line, y equal to 1. Now, you could have also said, okay, what if it's horizontal line whose y-intercept is, let's say, -4? So that would be y equals to -4 there. So we'd have this green horizontal line there. Okay, so that's how, again, you find the equation of vertical and horizontal lines. Now, really quickly, just so you can see with this example here, how the graphs are related of these horizontal and vertical asymptotes to the graphs of the rational function. Well, again, we saw with the vertical asymptotes that as x gets really closer and closer to, in this case, -3, the graphs of the rational function gets really, really close on the left and on the right hand side to these vertical lines. Now, for these horizontal asymptotes, what you'll see more is that if you were to zoom out more and more, that the rational function gets closer and closer to these horizontal asymptotes as you go off to -infinity and positive infinity. So if you go far to the left and far to the right. Now, what about just in general other types of lines. One aren't vertical and horizontal vertical or horizontal lines. Now remember, one way you could write the equation of a line is in what is called the slope-intercept form, which many of you have seen as y equal to mx plus b, where m is the slope of the line and b is the y-intercept of the line. So let's draw one of these lines, and let's see. Okay, let's look at this example here. So this is the graph of the rational function y equal to x squared minus 5x plus 3 over x plus 2. Now, just again another example of drawing a vertical line before we do the other line. So let's say if we want to draw the line x equals to negative 2. That's the one that just showed up in green. That's again the vertical asymptote for this line. But again, vertical lines are the form x equals to a constant. Now, if I wanted to draw the line, let's say y equal to x minus 7. That's what just showed up in purple here. That if you remember, if it's the equation of the line is y equal to x minus 7, so our slope is 1 because the coefficient of the x variable is 1. So that's saying our slope is 1 and our y-intercept is negative 7. Okay, so that would be this line here in purple. Now, just to show you again how this relates to this rational function, and again, if we zoom out more and more, what you'll see is that this rational function gets closer and closer to look just like the graph of the line y equal to x minus 7. This is what is known as, some books call it a slant asymptote, some books call it an oblique asymptote. But again, the way you would write the equation of these non-vertical and non-horizontal line is, one way is y equal to mx plus b, or again, m is the slope of the line and b is the y-intercept of the line.